Thank you. Can you hear me? Yeah? Yeah? Okay. Okay, so let's talk about ECMAScript regrets. Just a slide about me. Yeah, I try to put things that I do and try to find a common theme. So I try to improve the web. So I contribute to open web standards, mostly sending emails. I contribute to MDN, mostly to the JavaScript part of the documentation. I try to give HTML5 or JavaScript training. You can find me on Twitter or my email if you want to contact me. ECMAScript regrets. A regret, what I call a regret, is a part of the technology, HTML, CSS, JavaScript, DOM, whatever, that we wish was removed or fixed, but has to stay. In the first part of this talk, I'm going to talk about where do regrets come from and why we cannot fix the language. We wish it would fix, but we cannot, and why is that? Okay. To understand regrets, you have to understand how web technologies come to be. So this is like a way. Okay, so there is a well-intentioned spec writer who is writing perfect specs and then hand these specs to implementers, so web browsers. And these perfectly implement the specs. And then authors, so you, me, web developers, build awesome websites that work cross-browser out of the box. You're feeling the catch, don't you? And then users, yeah, okay, it's yellow, enjoy the aforementioned websites. Obviously, that's the ideal model. It doesn't really work that way. That's more the reality from the beginning to 2010. After 2010, things have gotten a little bit better. But how it worked was authors liked feature, some implementer drafted a feature, implemented it on its own without any coordination with other browsers, and then authors would make a website specially for this browser, and then users loved the new innovative website with this new technology, and then other implementers reverse engineer and make, and their entire goal is to interoperate, so they don't really care about making a good API or a good feature. They just want the new website to work with their browser, and that includes implementing awkward APIs and bugs. And then everyone gets tired, and so someone writes a spec to try to specify the subset of what's going on in what's common in all implementations, and try to figure out corner cases. This is what we call a de facto standard. It's when, yeah, in the ideal model, the specs come first. In reality, the specs come last. And then you may wonder, oh, okay, so maybe we can fix the web. Like, okay, so the first API is broken, but maybe we can fix it. Here is what happens when a browser tries to fix an API. They decide to diverge from the initial spec and remove or fix an API, and then some websites that actually rely on the old behavior, the broken behavior, this website breaks. This is what we call breaking the web. And then user accuse the browser and change it of browser, and so the initial browser loses market share, and no one wants to take that risk. And that's the reason we cannot fix the web. Like what happens in other languages. Like other languages make breaking changes. That doesn't happen in JavaScript, or it happens, but in very small cases. Only when we've demonstrated that it doesn't break websites. So yeah, so technologies cannot be fixed. This leads to APIs that we wish could be fixed, but won't be. That's what I call regrets. And so when I understood all of these, like all of that and all of and this part, I decided to start a list of all the things that we regret at least in ECMAScript. And so I started a GitHub repository, and I wanted to write documentation for all of them, and then I got lazy, and now it's mostly one issue per regret. So let's see examples. isNaN. Okay, so someone already know about it. So isNaN is broken. So we have this value, nan, not a number. That's cool. It has this property that nan is not equal to NaN, which is like, okay. So the language needed to introduce something to test whether some value is NaN or not. So isNaN was introduced. And that returns true for NaN. And that's cool. And obviously it returns false for other numbers, and it returns false for booleans, and it returns false for objects. Oh, it doesn't. Okay. Returns false for strings, returns false for all strings. Oh, okay. So it's broken. Even people who are, so that's a quote from a very recent email from someone who is a professional web developer in a standards mailing list. And so we talked about standardizing array.filter. So you know about array.prototype.filter. Array.filter is a Firefox specific thing that's not standardized. And at some point, when talking about standardizing array.filter, he mentioned that array.filter is NaN on Chrome. And I was like, oh my God, like, it's NaN in Chrome. What's like, that's completely crazy. And actually, that's not the case. Array.filter doesn't exist on Chrome. So array.filter returns undefined, and isNaN of undefined is true, isNaN is broken. So my recommendation here, okay, so ECMAScript 6 tries to, they introduced a new built-in number.isNaN that does exactly what you want, which is only testing for NaN and returning false for everything else. And so my recommendation would be to use a polyfill and stop using isNaN. Okay, other example, type of null. Type of null evaluates to objects, and actually it should be null. The reason for that is that in the very first implementation of JavaScript by Brendan Eich in the Netscape days, JavaScript values were represented in C++ as a type tag and the value. So the type tag would be a tag in 3 bits. So for the different types, so you have, string, number, object, etc. And the tag for objects would be 0. That's our first information. And then the null value would be represented in C++ as the null pointer. And in most architecture, that's just 0. That's just a bunch of zeros. So if you look at the tag value of the null pointer, it's 0, which is object. And that's the reason we have type of null equal object. So the recommendation to test for null is, well, mine is to triple equal null. If you do double equal, it'll test for undefined. Some people like that. Up to you. Testing for objects, I would recommend doing object x triple equal x. What this does is that it converts x to an object. And so if x is already an object, it returns the same thing. If x is a string or number, etc., it's going to return a new object. So it's going to be false. And ES6 tried to fix it. Some browsers experimented in fixing type of null, and it broke too many websites, so decided to not do that anymore. So to not do that in the end. Yeah. Another example, unique values should have a reserved keyword like. So undefined, NaN, infinity can be redeclared as variable, and function argument names. And, well, just don't do that. Just like it only creates confusing code. And my recommendation would be to use automated tooling to make sure that you're not making this mistake, like using undefined as a function argument or NaN as a function argument. I created an ESLint issue. Who knows about ESLint? It's a project by Nicolas Zakas. Well, he started it at least. And the idea is it's pretty much like JS hint or JS lint, but you can choose the rules and you can add a rule you can add a file per rule, so you can, it's really customizable. So yeah, I really recommend this project. So I created an issue so that a rule is created to make sure that you've not made that mistake in your code. Okay, another one. This is a function that creates a person. So the age is initialized, and then we'd like to increase the age every second, for instance. And this is not the this you're looking for. The reason is that each function declaration or function expression redeclares its own this. In this particular case, this is the global object, so this is really this you're looking for. The recommendation for ECMAScript 3 and 5, so web browsers, I guess, is to reference this in a variable. So first off, use strict mode, so that okay, sorry. In the previous example, if you use strict mode, the this in the setInterval function is going to be undefined. So setInterval is going to throw, so you're going to know about it, that you made a mistake. In that case, so what you do is that you create a variable that you call self or that or underscore this. And in your function, you refer to this variable. And here, there is no ambiguity over which this you're applying the h++ to. ES6 added arrow functions. And arrow function do not define their own this, which is good. And so this refers to the one from the outer scope. So that does exactly what you want. And it's much shorter. Stateful regexps. Who want to guess what this does? So we would imagine that it does true because foo is in both strings. It's actually not the case. Regexps are stateful, so I don't really know all the details, but the state, so, the regexp has a state that is related to where it stopped in the previous .test call. So, yeah. Like it should be stateless. So a recommendation: drop the G options when applicable. It's not always the case, but using .match always works. That's annoying. So so here, what you're trying to test if a property is not in an object. But the problem is that not is evaluated before in. And so what you end up testing when you do that is if false in object, which is never what you want to do. So the recommendation for your code is to wrap in parentheses. And I, again, recommend using tooling to warn you if you make the mistake. I created the issue, and a day after I filed it was already fixed. So thank you, ESLint people. So yeah, now you have automated tooling to warn you in case you made that mistake. I don't know how I'm doing on time. Okay. Conclusive thoughts. Regrets exist. So as you've understood, regrets exist because of how web technologies came to arrive in browsers. We cannot avoid them. Given that regrets exist, never assume, there must be a good reason why isNaN returns true for strings, and no, there is not. It was just a mistake, like Typeof null. Oh yeah, because null is like the prototype, and no, that's just a bug, like Brendan Ike, 10 days, JavaScript, so there is no good reason. So try as much as possible to understand why the language is this way. Yeah. And then I'd like to give a recommendation to avoid regrets from happening in upcoming technologies. So I suggest that authors, you, I, contribute to emerging standards. Mostly it's about sending emails. Just saying. And maybe even more importantly, we should be watching out for what's being implemented, because once something is implemented, so okay, just going back a minute. The tipping point of regrets is the second line here. As soon as a website, as a major website relies on part of an API or a particular behavior, web browsers won't want to break this website. So this is the point which we should try to avoid reaching. So either by contributing to specifications and making sure what will be implemented is good, and then making sure that what's being implemented is actually what's in the spec. So we should be watching out for that. Maybe contribute tests to W3C or to ECMAScript. And obviously, that's not only an ECMAScript thing. We have regrets in CSS. Oh, actually, someone else started it. That didn't call it regrets, but it's a page called an incomplete list of mistakes in the design of CSS. And thank you for them. My favorite is the box model with so when you do width and padding, by default, the width of your div is just the inner content. And so if you say, for instance, like 100 pixels and padding 20 pixels, it's actually going to look 140 pixels, which is not what you want. When you said width 100 pixels, most of the time you wanted it to look 100 pixels. And this line fixes it. It's just star box sizing, border box. I think for Firefox you still need dash mods, because there are a couple of corner cases where it doesn't really work, so they don't want to remove the prefix yet. But yes. DOM. Yeah, maybe the entire DOM should be a regret. I don't know. But yeah, this one, like, I just want to remove a node, and the shortest way to do it is node.parent node.remove child node. Like, no. Well, that's in DOM 4 they've added node.remove, so that it does that for you, and you can add a polyfill. But XMS HTTP request, again that API, it's good. I think the best API for HTTP request is the node.js API. It's really good. XMS HTTP request, it's terrible. The thing I hate the most about it is that we cannot do cross-origin requests by default, and it has to do with annoying, I believe, unimportant details, but others disagree, on security of intranets. But yeah, there is no like strong good reason about it. The recommendation here would be to have a, I don't know, proxy on your origin that forwards requests. Sort of annoying setup, but yeah. Local storage. There is this line in the spec where they tell you about how you should organize. So like if you are in a university, people tend to do like university blah blah .edu or com, and then slash, and for each student, tilde. I'm David Bruant, so D Bruant, and in this spec they tell you, oh, don't do that because every student is going to share their local storage, and so people can steal data from one another. Like, why does a spec about storing data on my disk is telling me how to do my URLs? Like, it doesn't make sense. It's just the complete opposite of loose coupling. We could do differently. HTML. Why link? What? Yeah. And the reason is that it would break other things if this was added to the spec. I don't know too much about the details about that, but yeah. Yeah, so ECMAScript regrets the GitHub repository, and I'd like to thank all these people for contributing to the repository, filing issues, discussing on, yeah. And I guess Brent and I for the language. Always fun. Thank you for the 10 days. Yeah. Yeah. Thank you.